What's up, YouTube? Today I'm going to do another past paper attempt. The previous one that I did was also from this February 2023 past paper. Bizarrely, I started on question 2, so now I'm going to have a crack at question 1. If you're also studying for the IStructE examination, subscribe to this channel so you don't miss out on any future past paper attempts like this one here, and you pick up on sort of any tips and tricks that I learn along the way as I also prepare for the exam. So, getting straight into it, question 1, the hillside building. So I'll quickly go through some of the client requirements that we need to make sure that we address in both of our schemes. So we've got a hilltop visitor center to be constructed on a sloping ground. So if you listen to my foundation analysis YouTube, I spoke a bit about what to do with a sloping ground, and that should be a red flag that you're going to need a retaining wall. Then they talk a bit about what the building looks like. Here's where we cannot put columns, so they're not allowed internally in halls, circulation areas, office, storeroom, toilets, and stairs, but are permitted within partitions and external walls. So that's where we can and cannot put columns. And then they talk about where some windows are going to go, and they might not state it, but it should be pretty explicit that we don't put a column or any bracing sort of straight through windows and doors. They've got a 1 meter high hand railing that sort of goes through the west edge of the upper hall. We'll have a look at the details, the architectural drawings in a second, but that's more or less through the middle. So it's really important that we read these client requirements because, they're our Bible coming into the exam. We need to make sure that we understand, appreciate, and satisfy all of these client requirements in both of our schemes. If we essentially don't, we're giving whoever your assessor is a really easy opportunity to deduct marks, and that's not what we're going for. We're going to show that we sort of understand the client's requirements and provide a viable solution. So can't stress that enough. Make sure that we don't skim read this stuff and really make sure that we understand it. And as I'm doing right now, I'm just highlighting the key facts here that need to be followed through. So obviously where we can't put columns, the fact we've got a sloping ground. They're not telling you there's a 1 meter high hand railing for nothing. So that's something that's going to have to be designed for and accounted for. Also here, this is something that took me a little bit off guard because, as structural engineers, we don't really pay too much attention to cladding, but it's one of 6 client requirements, so let's make sure that we address it. So the cladding to the elevations and roof need to be selected to minimize energy consumption. Okay, noted. I'll talk a little bit about how I address that in my attempts in a little bit, and also the fire resistance of the building. So they're all things that through sketches and commentary in section 1 that we're going to have a look at. Now this is a 7-hour paper and I'm going to try and do this video in about 15 minutes. So I'm not going to do section 1 and 2 here. I'm really just going to focus on the schemes of section 1 part A, which is 40 marks, and there's 100 marks in the whole paper. So it's nearly half of the paper squeezed into a 15-minute video. So imposed loadings, again, this is more relevant for section 2, but there they are. Site conditions, so it's outside of a city. Here are the wind speeds. Again, this is more for section 2 when you're doing your calcs. Ground conditions, this is very much relevant for section 1. And again, if you haven't already, go back and look at my foundation video where I talk about how to interpret the different soil conditions and what these properties mean. But at a high level, the fact that they're saying topsoil and they're not giving us any engineering properties, whether it's the N value from an SBT test or the unchanged shear strength of a cohesive soil, means that we don't intend on using this to bear any of our foundation material on. So if there's no values here, yeah, that's just a red flag that, okay, I'm going to have to strip this soil out, or I'm going to have to suspend on top of it and not rely on it as a bearing material. And then here we've got no groundwater encountered, so that's good, less for us to think about. So section 1, what we have to do here, we have to come up with sketches and sort of design schemes for 2 distinct and viable solutions. So I've mentioned this in my previous video, but I'll mention again here. So when it says distinct, that means it needs to be essentially different. We're not just replacing materials, we're showing 2 unique solutions. So, on top of maybe mixing up the materials, we're talking about different lateral stability systems, we're talking about spanning in different directions, columns in different locations, where permissible, different foundations. So yeah, that's what distinct is. So it's really important that we make sure that the 2 schemes that we're about to propose are distinct, they're different, and they also need to be viable. So viable just really means that they're hitting all of these client requirements, but also from like a structural engineer is going to be reviewing this, that these are structurally sound, safe, appropriate sized structural solutions. So let's get into what I've done here. So this is how I sort of plan to lay out my each of my schemes. So on the left hand side, I've got some brief descriptions, and I talk about some of the critical stuff. So description is literally 1 sentence in what the structural system is, and then I talk a bit more about the roof, floor, foundation, wall, and fire resistance. And I treat this as an opportunity to discuss key critical elements of my building, and what I've got in the red box here being in my opinion, the most critical, because that's talking about the stability of my building. But also it's an opportunity to sneak in how I'm addressing some of the client requirements that I wouldn't really be able to address in a sketch. For instance, like the cladding and the elevation and roof, it would be selected to minimize any consumption. For me, in my concept stage, that's going to be best addressed just with some commentary or some text, as well as my fire resistance. So going back to how I present each of the schemes, then on the right hand side I've just got a plan and a section or an elevation of my building system for the schemes. And then I also, just through some really neat, clear, simple sketches, illustrate the vertical load path as well as the lateral load path, just to show myself and my assessor that it's really clear how the load paths work. How does a gravity system work? How does a lateral load system work? And there's no ambiguity in terms of how the loads get back into our foundation. So what have I got here for my first scheme? It's a steel braced frame. Talk a bit about the roof in terms of which way it's spanning. I've got roof bracing as shown on plan, and I've addressed the insulation. So that comes back to the client requirements about minimizing energy consumption. The floor, I've got a ground bearing reinforced concrete slab. My foundation, as I mentioned earlier, we're removing the topsoil, we're replacing it with engineered fill, and I've got some shallow footings, which are my pad footings here. The foundation, I've also, as I highlighted, the fact that we've got that sloping soil, we're going to need a retaining wall. And one thing not to slip up on, as I've shown on plan here, it might be easy to think, and if I go to the section provided, you might look at this and think, oh, I need a retaining wall just through the middle here, but keep in mind that it's going to have to, try and think in 3D, that retaining wall sort of has to wrap around like this. So here the retaining wall is going through the middle there, but it also will be required on the sort of north and south elevations of your building. Wall, I just talk about using some cold form steel to support steel cladding, also addressing insulation because we're minimizing energy consumption with internal plaster. And then one of the client requirements was a 1 hour fire rating building. So the way I'm achieving that, and the way that I'm showing to the assessor that I understand the client requirements and how we're going to address it in this concept stage is some intumescent paint on the columns. So let's get over to some sketches. So I've got a member schedule here, and again, this is just concept sketches. In section 2 is when you actually do some sort of more detailed, accurate sort of like detailed design sketches. This is more concept, so I'm not sort of labeling every member, I'm just loosely talking about them here. So in the east-west direction, I've got my 410 UB beams. Keep in mind, all of these members here, I haven't done any calculations more than rule of thumbs. So that's just, when you come into the exams, make sure that you either bring with you or you memorize some rule of thumbs for different materials and structural elements. So that's essentially how I've sized up all of these steel members here. So in the east-west direction, spanning 10 meters, I got the 410 UB. In the north-south direction, spanning 5 meters, I got a much shorter span, so shorter members, 250 UBs running up and down the page. My columns are 250 UCs, and my roof and wall bracing, as shown here, are just some 16 diameter rods. So the blue highlight here was just for me to indicate, okay, that was just a prompt. Okay, there's a window here. Don't put any bracing through these sections. So I've avoided the bracing through any doors and windows, and it's in each direction. So yeah, that's critical. Then I'm essentially showing in section here as well. We've got the stairs going from the lower hall to the upper hall. There is my 1 meter high handrail, and I've got columns sitting on top of my retaining wall, and the handrail can just sit in front of the column there. And yeah, so this column here isn't within the upper hall or the lower hall, so it's satisfying those client requirements. Here's my pad footings, ground bearing slabs, wall bracing, etc. Again, just going back to what I mentioned before, we got some just show your understanding through some really neat and simple sketches. So here I'm showing the vertical load path, and it's literally just some vertical loads showing gravity loads. My blue line is a shear force diagram of the beams spanning that from east to west here. And then the beams are supported by columns. Columns take the axial load back into my pad footings, and the pad footings are bearing on the ground. And that is how my vertical load path works. Now, if we look at the lateral load path, we've got some steel bracing. So lateral load comes and hits the side of my building here, and it's taken by this strut. The tie takes it in tension. To close out the method of joints here, and for stability, this column has to be in compression, meaning we get this push-pull where this footing is resisting uplift and this footing is bearing onto the ground. This retaining wall here has to retain the earth, so it's resisting some lateral forces here. It's bending a bit like a cantilever. And the lateral load is resisted by the shear of the base here. So yeah, that's how I would present one of my first scheme, some description, make sure that I satisfy all of those client requirements. I really, can't stress this enough. Make sure that you show you understand the lateral stability system. You satisfy the client requirements, and then some descriptions as well as some neat clear sketch which shows that you understand the vertical and the lateral load paths. So now we need a second scheme here which is unique, as we mentioned, and also viable, so it satisfies the client requirements. So for my second scheme, I've gone with a timber frame with reinforced concrete shear walls. So I'm mixing up the materials, I'm mixing up the lateral stability system. I I talk a bit here about the roof. So my primary roof beams, instead of spanning the 10 meters east-west that we had here, there's our sort of 10 meters spanning east-west. Now we're spanning in the north-south direction, and these beams are spanning 15 meters. So given the further span, I've opted for a truss, which is a meter deep in the north-south. So that's my primary roof beams here. I've got some secondary beams in the east-west direction, also timber. They're 350 deep. Again, all of these just sized off rule of thumbs. My columns are 400 square glue lam columns. I've got push, compression, tension roof bracing in red here. So again, that's a slightly different system to what I had in Scheme 1 instead of the tension-only bracing members that I have. My shear wall is my lateral stability system, and again, I need it in both directions. So I've opted, in this instance here, I'm actually tying my shear wall on top of my retaining wall. So I saw there's an opportunity, two birds, one stone, if you will. The retaining wall has to wrap around sort of the east and west. So whilst you're pouring, that retaining wall is going to be really stiff. Yeah, it was a perfect opportunity, and we would detail it later. But in terms of section 1, where we're just showing some schemes, the orange here is just showing the shear wall sitting and a tie into my retaining wall. So, and the foundations that I show here are some screw piles. So that's getting to that stiffer clay with the much higher bearing capacity. So what do they say? This has got 200 kPa ungauged shear strength. So that would equate to about 500 kPa allowable bearing pressure, which is much higher than the medium sand that we've got here. So just as we did for Scheme 1, I talk about the critical elements. So here I talk a bit about the roof, the fact it's different members spanning a different direction. I actually need to update that. That was copied and pasted. So that is 15 meter span north-south. Anyway, the floor, I've opted for a suspended reinforced concrete slab spanning between these screw piles. So the benefit of that is, I don't have to actually strip off that top 300 of the fill that is on site. I can, when I bring in the piling rig and I get down to 2 meters into that, the stiff clay, now my slab, essentially, I don't have to excavate and replace any of that. So that's a benefit of this scheme. Again, I haven't updated this, but that is what is going on here. The walls, again, I'm just addressing the fact that we're going to be using insulation to satisfy that client requirement around maximizing the energy efficiency. And for the fire resistance levels of 1 hour, the way we achieve that, so we've got our primary elements are all timber and concrete. So for the timber, I'm not going into detailed analysis in terms of how we achieve that. I'm just at a high level describing how the fire resistance is achieved. So for the glue lam columns, it's a charring layer on the outside. So essentially we allow the surface layer of definite thickness to char, and the inside member is still structurally adequate. So that's how we achieve the 1 hour fire resistance of our columns. And our shear walls achieve it through an adequate thickness, which is the 250 thick reinforced concrete shear walls that we've indicated on our scheme here, as well as the distance to the reinforcement. So again, vertical load path, much similar to the previous scheme, but this time it is going into the screw piles, into a deeper layer. The lateral load path, again, just showing with some really simple, clear, neat sketches how the lateral load resistor system works, so whoever's assessing your paper can clearly see and understand and appreciate the scheme that you've put together. So here I show the lateral load coming into my roof, and it struts and hits the top of my shear wall. The shear wall bends, it's a force times a distance, and the shear wall being tied into the retaining wall means that moment carries all the way through to the base of my retaining wall. My foundations are tied into these screw piles, so I end up getting a push and a pull on my screw piles, and that is what stabilizes the lateral load. So yeah, there's my load path, my lateral load path, there's my vertical load path. Here's what it looks like in section. In plan, this scheme is different. It's distinctly different to the first scheme, different members spanning different directions, different lateral stability systems, different floors, different foundations. And it's also viable. It's satisfying all of those client requirements. We're not putting columns in any of the areas that it's not allowed. We've kept access to all of the windows and the doors, etc. So I haven't got any commentary at the moment in terms of which scheme I would choose. One thing to keep in mind, whatever scheme you choose, you have to go and follow through in section 2. So whilst you can't use it as an answer, but do keep in mind which scheme you would actually feel more comfortable in doing a set of detailed calculations on. For me, that would be the steel brace frame. So I would be inclined to recommend the steel brace frame as an opportunity for me to go and provide calculations in section 2 in something that I'm more familiar or comfortable with. So at a high level, the things that I would describe as benefits of scheme 1 over scheme 2 to the client is, for me, the main one is the primary beams they're spanning a shorter distance. So here they're spanning 10 meters. In scheme 2, my beams are spanning 15 meters. So remember bending moments, WL squared on 8 for simply supported beams. So limiting the span results in sort of more efficient use of materials, less load on the foundations, etc. So that is a material efficiency by just limiting our span lengths from 15 meters to 10 meters between scheme 1 and 2. The lateral stability system for a single story building, like the brace frame, the steel diagonal bracing would be sufficient and much more economical than the reinforced concrete shear walls provided in scheme 2. Whilst both are appropriate, one's a fair bit more economical than the other, being just some 16 diameter rod. So that's another benefit of scheme 1. And then my final benefit of scheme 1 over scheme 2 is the fact that we don't need a piling rig. So we've got shallow foundations. Our shallow foundations mean I don't need to bring out a piling rig on site because I've just, my foundations are much shallower. And for a fourth option that you might recommend scheme 1 over scheme 2 is the fact that the slab is actually bearing on the ground. Because we stripped off that top 300 of topsoil and replaced it with a superior fill, our slab is now bearing straight onto the ground as opposed to being suspended off piles. So we should be able to get away with a thinner slab. So yeah, they're the two schemes that I have. They're the reasons I've run through with scheme one. I did highlight before that a part of me wants to follow through with scheme one because I'm more comfortable with it. But again, that's not one of the reasons you put forward to the client. That's something you keep to yourself. You have to put actual engineering rationale in terms of why you're suggesting whatever scheme it is that you're choosing, to the client. If you're intending on sitting the IStructE exam and you want some more help, or you don't want to miss out on any of my future past paper attempts or any tips and tricks that I share along the way, make sure that you subscribe to this channel so you don't miss out. Thanks.